So we can go back and revisit motion now that we've talked about the trig derivatives, because trig derivatives are used when we're talking about simple harmonic motion. And this is repetitive motion. Think a weight bouncing on a spring. If you pick a point on a bicycle tire and follow it around, it repeats itself over and over and over again. So any type of motion that's repetitive is harmonic, and simple harmonic means it's not changing as it repeats. So if we say our displacement is 5 times cosine t, what this can tell us is that the position is oscillating between the minimum and maximum of that. Well, we know cosine goes between -1 and 1, and if I multiply that by 5, this will be between -5 and 5. We can also say that the period, because we know the period of cosine, is going to be 2 pi. So it is oscillating between those over a period of 2 pi, which then repeats. So if we find the velocity, well, that's still the derivative of displacement, so that would be -5 sine of t. What this tells us is that we will be stopped whenever this is 0. Well, sine of t is 0 when t is equal to k times pi, and k is an integer. We could also say that we have a maximum speed. Now please note I'm saying speed, not maximum velocity. So maximum speed whenever this is going to be at 5 or -5. And that would occur when sine of t is 1 or -1. And sine is at 1 or -1 if we have L times pi over 2, where L is an odd integer, which would give us multiples of pi over 2. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. So then if we move on to acceleration, acceleration is the derivative of velocity, which will be, in this case, -5 cosine of t. What this can tell us is that we have a maximum acceleration when this is at 5 or -5, and that occurs actually in the same place that velocity is stopped, which would be at k times pi, where k is an integer. We could also go ahead and talk about when there's no acceleration, in other words, that we have a constant velocity, meaning no acceleration, or acceleration is 0, I should say, not no acceleration. The acceleration is 0, but a constant velocity would be when this is 0, and that occurs at L times pi over 2, where L is an odd integer. And so what we can see is that we have constant velocities when we have a maximum speed, and we have maximum accelerations when we have a 0 velocity. And if you can picture in your mind a spring bouncing up and down, that does tend to make sense. Then finally, we could talk about jerk, which is the third derivative of displacement, second derivative of velocity, or first derivative of acceleration, which in our example would be 5 times the, whoops, not cosine, 5 times the sine of t. And there's not much that we can add to our description than we have already.